Hey guys, this is Mrs. White and Mrs. Hurst again doing 2.5 reasoning in algebra and geometry. And technically when we talk about reasoning, we will get into two-column proofs. When you ask your parents about what they liked about geometry or disliked, typically they say, I hate proofs. So we're going to be doing that section today.
But we love proofs.
We love proofs. Alright, so what you guys need to do right now is we went really high technology and we copy and paste straight from the textbook, which is on page 113 and 114. So you definitely need to copy each one of these properties down. You've seen pretty much most of them, and correct me if I'm not wrong, Ms. Hurst, since you've taught Algebra 1, do you go over reflexive and symmetric?
Yes, we do.
Okay, so all of these are Algebra 1 properties. Okay, so this is just a little recall refresher. And then don't forget about this property down here, the distributive, which most of you guys get. That's the one you guys know most of. So copy all that down and get that in your notes. And what we would like you guys to do now is to actually do some practice problems. There are 9 of these, so write them down and then see if you can name the properties. This is how the properties will look like on your test and quiz. Sometimes there's numbers, a lot of times they're just letters. Variables.
So once you've got all your answers down, go ahead and unpause it and we'll show you what our answers are.
Alright, so answers 1 through 9, so go ahead and check over your answers. Oops, get the last part there.
Now the reason there's an equal sign in the parentheses is because these are the addition property of equality, which in Algebra 1 you may remember there was a property of inequalities. We want to make sure we're very specific when we do this. It's okay to abbreviate, like we said when we were doing previous things. P's, Q's, LOD, LOS, we like to abbreviate.
Alright, so let's get into the fun stuff. You've actually done Algebra 1 proofs before, and you guys did this to help you logically think through what steps you're doing to solve the problem for X. So we're going to start and refresh your memory how to do a Algebra 1 proof, then we'll progress and do Algebra 1 and geometry proofs, and then later on we'll just do straight up geometry proofs. So
take a second, make sure you write this down. It's very important that you pay attention to what's given and what we're trying to prove. And you'll notice that this is in 2 columns. Every proof that we're going to do this year is in 2 columns. So go ahead and set this up on your paper, and then when you're ready, go ahead and we'll talk through it with you.
Alright, so the first step under the statements gives you the equation, 2x plus 3 equals 4x minus 2. So if we look back up here, that is what they gave us to start with. That's the given equation. So our reason, whenever it's the given, is simply the given. Okay, so make sure you just read, like Ms. Hurst said, what's in the given, find that in one of the steps, and it's always going to be one reason. That given will be in every single proof we do, algebra and geometry-wise. So now, from here, when you look at an algebra proof, you have to see what do you do from step 1 to step 2. So looking at this, we notice that what happened to the 3? What did we do with that? So
the other question is, where did the minus 2 go on the other side? It's gone when you get down to step 2. So, well, if it's gone and we got to the other side and 3 is now 5, what did we do?
Well, we added plus 2 to both sides, which gave us a 5. So what property is that?
The addition property. Now, the addition property only is valid if you add it on both sides of the equation, like we did in this step.
Okay, so then from here, from step 2 to step 3, it says we have 2x plus 5 equals 4x, and then it comes and we got 5 equals 2x. So what happens here is we're taking this 2x and moving it over there when we're solving this equation because the 2x is gone from here. So to get rid of that 2x, we are subtracting a 2x from both sides from step 2 to step 3. So that property is
subtraction. And again, this is the property of equality, so we are going to put the equal sign. You don't have to put the word prop or the property, just, it's okay, it's technical.
And then finally, from step 3 to step 4, we're getting x by itself because that's what it's asking us to prove here, the 5 divided by 2. So to get rid of the 2, we're dividing both sides by 2. So our last step is division property.
Now, sometimes you'll see an extra step added on here because if you notice, this isn't facing the same way or written the same way that it said to prove it. This is backwards. So if you think back, this is how we want our answer. Just to switch those, if A equals B and B equals A is how you saw it on the previous page, and that was your symmetric property. Miss White and I are both okay if you leave your answer like this when you're writing your own proofs, but you're more than welcome to use that symmetric property and keep going.
All right, so what we would like you to do right now is pause and try to do this algebra proof on your own, and we'll show you the answers in a second.
Okay, so hopefully you guys had enough time to do that. These are the answers you should have come up with. If you have any questions, think about writing these down as your questions for the lesson and bring them to class tomorrow.
All right, so this is where we're going to incorporate some geometry to start, and then we solve the problem with our algebra. And if you look at this, this example right now, it gives you a line segment with t equals 10, ed equals 2x plus 5, and td equals 25. Every time they give you a diagram and a geometry proof, I always emphasize to go ahead and label your diagram here, just like we were doing without a proof. Label everything they give you. So go ahead and read the given, label that, and then label 25. So I always tell you, you guys are actually able to solve this proof on your own, or this example, I'm sorry, without doing a proof, because we've done this from chapter 1. Because what we're given is a segment, and we needed to solve for x, so you guys had to set up your own equation. Does anybody remember which postulate we used to set up this equation? Hopefully you can think and remember it's the segment addition postulate. Okay? And if you remember what we said for segment addition postulate, I abbreviate, it's the part plus the part equals the whole thing. Okay? And segment addition postulate, that's what this says right here in this step. Okay? TD is the whole thing, the whole part of this line segment, and then this is your part plus your part. So this is the geometry part of a proof. You'll do segment addition postulate, we've done angle addition postulate.
We'll talk about angled bisectors, midpoints, just about any definition we've given to you can be used when you're writing a proof. Now, you'll notice that we didn't start at step 3. Okay? When you're doing this on your own without writing a proof, we probably would have started at step 3 and just set up the equation to solve. But since we're trying to convey a proof to whoever is reading this, we need to start at the beginning. This is the given information, and based on that, this is what I know. I know that segment TE plus segment EB will add up to be the whole thing. Now we can go ahead, and I'm not going to give away the reason for number 3 right now, but go ahead and figure out what those reasons are while you're solving this example.
And hopefully you can come up with these answers here, the algebra properties. And if there's more questions, obviously in class we can talk more. We're going to work a lot more proofs in class. All right, so now here is another example where if you look, we're given a diagram. So we're going to start with geometry. Okay?
Now, if you guys want to think about what you would put first and see if it matches what we come up with, we're going to do this one step at a time with you guys. Take a second, write down everything that's in front of you, write down your 2 columns, and see if you can start without us. Make sure you're using pencil just in case we come up with something a little bit different.
So hopefully you got the first one right, because you always start with a given, and I just tell you guys just to read through, and all you're doing is just recopying that given part for the first step. All right, so step 2, if you look at our diagram, you need to remember what types of angle pairs are up there, what we're given. So hopefully, number 2, you might need to think about now after you see the answer, because supplementary, these 2 angles here, BAL and BAT, are supplementary because they're on a straight line, which is the definition of linear pair. So that's that geometry part where you have to state that what they are, what the angles are, kind of like the segment addition postulate we talked about yesterday.
Basically, you're trying to illustrate to somebody who doesn't know geometry why you know the things you know. Well, I know that this is going to add up to be 180 because I know this is a straight line, because therefore these two angles will be supplementary because they are a linear pair. So you have to be very specific.
So now that you know that they are supplementary, just like the segment addition postulate where we did part plus part equals whole thing, well, we know they're supplementary, so we know the angle BAL plus the angle BAT, those measures are going to be 180 because that's the definition of what supplementary means. Okay?
This is the last one we're going to give you, and then we're going to have you finish the rest of this on your own because it is just an algebraic proof after this.
And it might seem a little confusing right now, but there is a pattern. Every time, you know, when we're doing practice problems, if you see these angles like this and they're a linear pair, these are the steps they're going to follow. There just might be different numbers and different letters. So it just takes a little bit of practice to get used to it first.
Now, for this one, we said it was substitution because we said BAL was 2x plus 5. Well, here's BAL in statement number 3, so we're replacing that with 2x plus 5. Then we said that BAT was 3x. Well, here's BAT right here in statement 3. Here's 3x. We're replacing it then.
Right. So, and I just remind you guys, every time you go from like letters to numbers, you're pretty much substituting in those numbers for what you're given. So when you go from geometry to algebra, a lot of the times that's what the reason is.
All right, pause and see if you can finish the rest of this proof and then come back and check your answers. All right, did you guys come up with the same thing we did? If not, if it's close, keep it on your paper and we can discuss that in class tomorrow because there are some variations that could take place.
All right, so that concludes our proof introduction. And like I said, we're going to be working a lot more with proofs throughout tomorrow in different ways. You will see proofs in our textbook in our course.